Alright, hi everyone, welcome to my YouTube channel, CTF Elections. So in this video, we are going to talk about the relationship between torque and rotor power factor. So recall that the idea of the formula for torque is like similar to that of the DC motor, okay? And torque is in Newton meters, okay? Newton meters, force, and then the distance. But of course, this one has to do with rotation. So torque has to do with rotation. Okay, so recall that in DC motor, the torque TA, that's the armature torque, is proportional to the product of the flux per pole and the armature current. That is what we have here. Okay, now similarly in an induction motor, the torque T is also proportional to the flux per stator pole and the rotor current. Note that the power factor of the rotor is also considered. So this is kind of the difference. This is kind of the difference between the DC motor and then the induction motor for the torque. Now look at it. If you compare, they are the same, except for the rotor power factor. This guy here, okay. Except for this guy, the rest part T. Okay. Of course, the subscript A just indicate that this is the torque for armature current, and this is the torque for the rotor. Okay, so it's almost like rotor. For induction motor, we'll talk about the rotor current, the rotor torque, while for the DC motor, we'll talk about the armature torque. Okay, so of course, the flux and then the armature current. Flux, rotor current. I was saying it now. Just that in this induction motor, we now consider the power factor of the rotor power factor. Okay. Then of course, when we introduce the proportionality constant K, here this sign becomes equal sign, and then we introduce K, which is the constant, and then the rest things of course remain the same. And then we just define the terms, saying that where this is the angle between the rotor EMF, that's E2, and then the rotor current. Look at this diagram here, okay, where we have in the adjacent side you have the resistance, and then the opposite side you have the reactance. So without we can say the flux, okay, is the tan inverse of reactance over the resistance. Note that anyway you see this subscript 2, we are talking about the rotor. Okay, all right. Then of course the X2 is the reactance per phase for the rotor at standstill, and then the resistance R2 is for resistance. Okay, now same diagram I drew up there, which is this diagram. Okay, just same thing here, but of course this side, the hypotenuse side, is the one we use the Z, which is impedance. Okay, we use the impedance there. So this is just the idea for relationship between starting torque and then the power factor. Okay, I hope that's clear enough. So with that, we'll just let's just add starting torque as part of okay, we'll talk about this in the next video. Okay, talk about this in the next video. Make this brief as possible so you can watch over and over again and get what is being done in this particular video. And in the next one, we'll talk about starting torque, which will be really fast. Okay, so thanks for watching, and like, share, subscribe, comment, and I'll see you in the next video. Bye for now.